In this lab, we're going to work with Anaconda and work with a notebook that contains some attack data, some labeled attack data, and some normal data. So basically network traffic that we're going to analyze using Jupyter Notebook. So I'm going to start by opening Anaconda. With Anaconda open, the next step is to open Jupyter Notebook. So you'll scroll down to Jupyter Notebook and click Launch. All right, with Jupyter Notebook launched, the next step then is to start a new notebook. I'm going to click on File, and then New, and then Notebook. And if you're prompted to select the kernel, you can click Select there. All right, now we're within Jupyter Notebook, and I'm going to load the data that is related to this lab. And you can find the data linked from the description of this video. You'll be able to find a CyberLab dataset. That is a dataset that is synthetic, and it's based off of other datasets that you might find, but it's a synthetic dataset that we're going to use just simply to make things easier for class here. I'm just going to display it in Notepad++. And we can see that that data is already not only labeled between normal and attack, we see that final column within there, but we also have the names of each one of the features or each one of the columns within this CSV or comma separated value file. All right, so we have that data there. I'll just close it. Next thing we want to do is we really want to work with this programmatically. And in order to work with it programmatically, we're going to create a Python program that will help us to do that. And we're also going to use Pandas and Matplotlib, a couple of extremely useful libraries related to working with data in Python. When we work with Jupyter Notebook, if you're not familiar with it, Jupyter Notebook works with the concept of cells. And each cell can be executed individually. And so what we're going to do is just begin typing within Jupyter Notebook. And we're going to import pandas, P-A-N-D-A-S, as PD. And we'll also import our Matplotlib library that we're going to use. Helps if I spell it correctly, Matplotlib. Okay, so with that done, we can just simply run that selection. We don't really expect any output. Python was able to run that, our 2 lines, but it enables, when we work with the cell concept, it enables us to debug things very easily. We don't have to worry about a 100-line or more file and where are all of the errors. We can just simply work as we go and work with what makes sense for the data that we're trying to analyze. In this case, we're really just trying to look at the data and figure out a little bit more about it. Maybe its shape, maybe if there are things in it that are interesting and we want to take a look at those. And so we're going to be able to do that with Jupyter Notebook. And it's going to make it easy to do, almost like a graphical interface for it that can be quite helpful. All right, so let's continue then. The next thing to do is to create a data frame, and that's typically, you'll often see that abbreviated as DF. And I'm going to use that same convention here, and we're going to use pandas to read that CSV file using the read CSV function. Now things get a little bit tricky because that file is located in my downloads directory, right, which is probably within my home directory on the computer. So we have a couple of different choices as to how we get access to it. I'm going to try this method, and it might error out, but the great thing is you might get the same error, and so then you'll see how to fix it as well. So on this machine, that is how it should look. Whoops, I need to escape each one of the backslashes by adding an extra backslash. Windows likes to use backslashes instead of forward slashes to denote folder structure, and when we do that programmatically, we frequently need to escape that backslash for a variety of reasons that we won't get into here in this video. But again, I'm experimenting here and seeing if if this works. It might not work. And that troubleshooting is sometimes helpful. So it's called cyber_lab_dataset.csv. And I'm just going to try to take a look at the first few lines of that file if I'm able to read it. The first few lines of that data frame if I'm able to read it. So now here goes nothing, and we'll see in real time if this actually works. And it did. Again, so wherever you download that to, and it might end up just being downloaded into your downloads directory, just note that you need to add those double backslashes if you're on a Windows machine. If you're on Mac or Linux, you won't need to do that type of magic, but you'll still need to find where you downloaded that CyberLab dataset to in order to get access to it there. All right, and so then we can see, thanks to the head function, we see 5 rows of that data. We see each one of the feature names there. We have the flow duration, the protocol, source and destination IP, total forward, total backward packets, and then also the label. And remember, we talked about supervised versus unsupervised learning in the lecture. And of course, then this would be supervised because we already have a labeled data set. If we want to take a look at that data frame a little bit closer, or just sort of get an idea of what's in it, we can use the shape function. And I'll just run df shape and see that it doesn't work because I called it as a function. It really is a property. We see that there are 10,000 rows and 7 columns, or 7 features within that data set. So that's df shape. If we want to find out more information about each one of the columns, and notice that data frames use the concept of columns, we will call or access that property. And we see that there are the following column names within that data frame. Finally, we have the info function. That can sometimes be helpful to help us find out what data types we are working with. And we see we're working with integers and objects for data types within this data frame. Another way to get at some of that information is through describe. When you spell describe correctly, that is. And we have some more information here regarding the data frame itself. We have a count of the number of rows, so that's similar, getting access to some of that other information that we got to with shape. But then we also find out about the mean and so on. We have some of the mathematical functions here. All right, so what's the goal here? Well, we have data. This is, again, just a synthetic subset of data, just 10,000 rows. That University of New South Wales data, there was a lot of data there. If we would have downloaded all 4 of those CSV files, we would have had a lot of data to go through. And so as a cybersecurity analyst, you're inundated with data. There's just too much data really to go through and make sense of. In this case, we have data that's already been labeled. And it makes life a little bit easier because we know normal from attack based on the labeled data that we have within the CSV file for this lab. The problem is data is not always labeled, right? And so we're not always going to have that label there to be able to differentiate normal versus attack just in a nice column. Therefore, we want to look at the other features within that data, the other columns within that data, try to find something that looks similar. So what types of characteristics would an attack have versus normal traffic? Are there things that look different about attacks versus normal traffic within the data that we have? And one of our jobs then, before we can get to machine learning, before we can get to AI, is to look at the data. And you're going to do this as part of the process of building a machine learning model. You're going to need to look at the data to try to find the areas of interest, try to find the features that are interesting, that help to tell the story, that help to indicate normal versus attack, or something that you want to pay attention to versus something that isn't important from a cybersecurity perspective. So we've looked at the data a little bit, we've described it and so on, but let's take a look at a little bit more detail here, some filtering and maybe some selection that we can do here. So let's work on a subset of that data and build out a data frame that's just TCP traffic. I'm scrolling up just to see the column names. That column name did start with an uppercase P, and that does matter. You might see me do it wrong, but hopefully this time I didn't do it wrong. All right, so I'm going to build a data frame called df_TCP that's going to contain the data that is only related to TCP, or Transmission Control Protocol. All right, let's run that, and yep, that ran without problem, so I had the case sensitivity correct. Sometimes I don't. All right, so df_TCP. Let's do that shape. Let's look at the shape property again. So we see that out of the 10,000 rows that we have, 7,058 of those rows are TCP versus UDP or some other protocol. TCP is the majority of the rows that we have. Let's take a look. Let's see what else, other columns do we have that might be interesting. We have the flow duration. So let's take a look at flow duration and build a variable out. Let's call it long flows. Now I need to scroll back up to find the case sensitivity on this. It was uppercase F and uppercase D. And let's look for things that are greater than 10,000 for that duration. And again, hope that I did things right here. Well, we can combine both. Let's just get that data right away. So hopefully I did things right here. Let's find out. I did. So out of those flows then, 8,631 out of the 10,000 have a duration greater than 10,000. And so that's microseconds, by the way. So maybe that doesn't help to tell the story. Let's try 20,000. And now we're down to less than half that have a flow duration of more than 20,000. How about 50,000? Now we only have 203. I'm going to switch that back to 10,000 just for demonstration purposes here. And so then let's take a look at some feature engineering. So we've got some interesting information here, although I suppose what we should do is take it a little bit further. And now, because we have that flow duration and we have TCP, are those factors important? Is that flow duration important as to whether the label will be attack or normal? And so let's take a look at the attack rate for TCP. I think label had an uppercase L. Power of positive thinking, it does. Okay. So df label, df_TCP, and then we want the label column out of there. And if it is equal to attack, which is spelled with 2 T's, then it's interesting, right? So let's take a look at the mean for that. And I may or may not have my parentheses here correct. But let's take a look at it nevertheless. So now the attack rate, because there were so many TCP packets within there, TCP flows within there, that attack rate, the mean might be somewhat low. Let's take a look and do the same thing with the length of attack and find out if something in the duration of that attack helps us to discern whether or not a given flow is indicative of being an attack versus normal traffic. I did it again, ATTACK. And what did I do wrong? I did not put an equal sign there. Okay, so that's easy enough to fix. I'll just go back up and put an equals sign there. I should have had one there before. And now let's rerun that cell. What did I do wrong? Long flows should have an S on it. Maybe you spotted those problems before I did. All right, so now we see that the mean there for attack rate TCP and the mean for attack rate long are roughly the same, although maybe a little bit different, right? In reality, those can be somewhat different. Maybe it has a slightly lower or higher attack rate. Maybe longer flows correlate with higher packet counts, and so that might alter the duration, because if we're doing exfiltration, if we're stealing data, that might be indicative of a longer or of an attack versus a shorter duration flow, which is not indicative of an attack. As we work with data, we'll find, and you can experiment with data to find labels or find those columns or features that might be helpful for indicating an attack. And using something like Pandas, or Python in general, but Pandas in particular, and in Jupyter Notebook, it enables you to experiment with that data. And you saw how easy it was when I messed up the name of the variable there that I had created, name of that data frame, and then also forgot the equals sign. You saw how easy it was to just go change that and then press play again. Makes it trivial to do that. Let's talk then about feature engineering. What we want to do is to create a new feature here within our data frame, and let's call that packets total. I'm never going to get the case correct for this, so I'll scroll back up. I'm looking for total forward packets, total backward packets, and looks like those are initial case. So FWD and plural packets, right? Hopefully. You might be yelling at the screen saying it wasn't that case or it wasn't plural. I think it was singular backward, but then plural packets. And so if we look at the feature that we just created, it is essentially created on that data frame. We created packets total, and I'm slightly bothered that I only use lowercase here when everything else has been initial caps. But I did it anyway. And let's say that I did it on purpose, because then we know that that's a feature engineered feature that we've added to there, an engineered feature that we've added to our data frame. In any event, what we've done then is group by the label. And we've grouped by the label for that packet's total and taken the mean of it. So notice that when we've labeled, then when the given row or when the rows are labeled attack, we have many more packets being passed. 18 versus 59 when we're labeling attack versus normal. So as a cybersecurity analyst, I would say, wow, if there is an attack, one of the things that we might look at, something we might want to consider, is the number of total packets associated with an attack, because it's significantly higher. The problem is, of course, now we get into, as we're looking at triggering an intrusion detection system or a response, does every packet flow that's above, say, 50 indicate an attack? Is it 40? Is it 30? Is it 20? Or is it 18? Well, that's just the mean of that. That's the average. So we would want to look deeper, or we certainly wouldn't want to hard code something to block every packet flow. that's labeled as an attack only based on this criteria, only based on the total packet criteria, because we might be missing some cyclical activity. Let's say every 2 weeks the payroll gets sent out, and that is something that might skew that mean, the normal mean, higher, because it might take 50 packets for that flow, and now suddenly we're automatically blocking that. Nobody gets paid, and they come knocking on the cybersecurity analyst's door, wondering why they didn't get paid this week. And that's not somewhere that you want to be. So it's, again, one of the problems that we have in cybersecurity is we can't hard code things, and we can't always say, just based on this one single factor, we're going to block that entire flow. We're going to stop that from happening, because it's just a data point, right? A data point on an attack might be that it has a higher traffic flow. So now if we're scoring that and we say we need to, if something gets to a score of 5, it earns 5 attack points. In other words, so if the duration is long, if it is TCP and the duration is long and the number of packets is greater than 50, then add 3 points to that because it looks like an attack. Well, now there's maybe another factor that makes it look like an attack, and we add 2 points to that. Suddenly it reaches that threshold. That's how a lot of spam filtering is done, based on a certain threshold. If there are a number of factors that all add on a number of data points, each one of those data points has a certain weight to it. And that weight, once it reaches that threshold, whatever that threshold is that we define, suddenly then we block that email as spam. And that's probably how we would use this, at least at the point that we're at, is we would look and say attack flows are significantly longer. They have more packets associated with them. And that's a data point that we would have. All right, our next task then is to do some visualization, because that can help us to find features that are interesting for what we're doing. And so we're going to employ Matplotlib. Recall way back at the beginning, we imported Matplotlib. So now let's start using it. All right, so what I've done is created a histogram of flow duration. That's what we're doing with the code that I typed in. We are creating that histogram and using 40 bins. That's a number that I chose, just having worked with similar data in the past. You might need to experiment with the number of bins in order for the data to make sense. And by the way, it's easy to experiment with the number of bins simply by doing something like that. So 4 bins doesn't help us to tell the story, although a little bit it might help us to tell the story, right? Because we can see that a lot of the flows, a great number of those flows, are less than 20,000 microseconds. And between 20,000 and 40,000, we have almost all of the flows accounted for. But anyway, 40 sometimes works, or at least worked for this data, and helped us to show that most of that traffic is under 20,000 microseconds, and that helps us to visualize where we might look for outliers. We might look for things that are anomalies in the data, which we often do in cybersecurity. Well, that's what happens when you press too many buttons at once. All right, let me go back up into there. I wasn't nearly done. So take a look at our traffic. When I do a simple bar chart of normal versus attack traffic, the labels from the CSV file themselves, many of them are normal. The vast majority are normal traffic, labeled as normal within there. Less than 2,000 are labeled attack within our data. And now take a look at this box plot that I've created because it really helps to tell the story. When we have attack traffic, notice that the packets total is significantly higher. That range is higher than normal traffic. So even though we have so much normal traffic compared to attack traffic, that packets total really does help to tell the story within our data. All right, so I hope you found this video helpful for just an intro to data exploration using Jupyter Notebook, using Pandas and Matplotlib. We've looked at some data that's related to cybersecurity, specifically that subset of data that we created just for this lab, and it was labeled data. We're really preparing with supervised learning here and getting towards that, but we're exploring that data first because we need to help understand the data and understand the features within that data that will help us to differentiate between normal and attack traffic. So once again, hope you found this video helpful. Thanks for watching.